Yeah, okay, so this is not metal. This is good old. Hey curious people, welcome to How's It Made. Today I have the BOSCH IMPACTOR 18V impact driver, and in this video I am going to be tearing it down and seeing exactly how and how well it is made from the perspective of myself, a practicing product development engineer. So let's get to it. So before we tear it down, let's take a look at what we can ascertain from the outside. Get that off of there. So first thing I notice is this overmolded integrated grip is very sticky. Not sticky, like candy, but it's very grippy. Soft, nice texture, really grippy. Really more grippy than some of the other brands that I've felt. Moving on, this hard plastic housing has a nice matte semi-orange peel finish to it. Nice looking logo. This right here is an even softer rubber, probably for gripping while you're holding on to it. It doesn't, oh yeah, it's not, that's not overmolded. It's a separate part, probably a thermoplastic elastomer, which means it melts if you try and burn it, as opposed to your car tires that will just burn and not melt, or not melt back to their original state anyway, put it that way. Anyway, this feels like cast metal, but I've been fooled before, so we'll wait till we get into it. That definitely has a nice feel to it, all metal. Polyamide 6, glass filled 30%, and SEBS. So the rubber is SEBS, just like some of the ones that drivers that we've reviewed in the past. And similarly to other drivers, this is nylon 6 as opposed to nylon 6.6. Nylon 6.6 is when you say nylon, you mean nylon 6.6. That's what nylon means in common parlance, but there are many forms of nylon, lesser known and lesser used forms, and normally you would use the 6, the less common 6 form, when you need better surface finish, better coloration, and potentially better long-term impact resistance. Nylon 6 will absorb more moisture over time from the atmosphere than nylon 6.6 will, and you might think that sounds like a bad thing, but it depends on what the application of the part is. So if you want the part to be very impact resistant to hard strikes from dropping it or impacts with hard objects, then you want to increase its impact toughness. And in plastics, most plastics, increasing the moisture content will increase the impact toughness. And so over time, the impact strength of nylon 6 will go up higher than it will inevitably for not traditional nylon 6.6. And again, it depends on your environment. If you're in Arizona with borderline zero humidity versus Florida with actually 100% humidity on a regular basis, then that's going to change a little bit. But the potential for the impact strength for nylon 6 is higher. So there's the specs for it if you wanted to know. Made in Malaysia. That's pretty interesting. So that whole contact platform is compliant. You see that little spring right there? It's got that built into it. So when you put the battery in, yep, it bounces back. So that's probably to help with when you drop this, and even if it doesn't come out, if it stays in, it still maintains contact with those electrical contacts. I don't know if you've ever experienced it, but some impact drivers, when you drop them, the battery won't come off, but you'll have a dead trigger. And that's because inside something has jarred loose enough to prevent enough electrical contact to make the motor work. And so I'm guessing this design really makes that darn near impossible. If that battery stays on there, that is going to absorb the blow and maintain electrical contact. Now, I'm sure the battery can still fall off, but if it stays on, it stays contacted, is my guess for what that is. Mechanical compliance is always good to have, unless the design requires rigidity. If the design requires rigidity, then you can't always have compliance. But if you can have compliance built in to a mechanical assembly, you will prevent so many problems and increase durability and reliability. So there's chemical compliance that they're building in by using the nylon 6, building that into the very structure of the polymer by their material selection, and then mechanical design compliance by way of that spring and making this platform be on a sliding motion. So that's pretty cool. Something you might miss unless you've failed by making things too rigid before, which I have definitely done. All right, well, I think that's all I can tell from the outside, so let's get this thing apart. Okay, so there is definitely a lot going on in here. The first thing that comes to mind is the order and the planning that went into the ribbing structure here. Might not seem like a lot, might kind of seem like it's thrown in there kind of willy-nilly, but I can see the order and the kind of design rules that were used in adding those ribs, and it's definitely a little bit higher end than what I've seen in some other teardowns, which is kind of something you would expect from Bosch. Is definitely one of the higher end brands, up there with Milwaukee and probably a couple others. But this is a very structurally sound design. A lot of planning went into these ribs. You notice there's ribs just about everywhere that they could fit a rib, that they didn't actually have to put another component. They put a rib. You know, they spider. You know, it looks like spider webs is, and there's a reason certain designs are seen in nature, is because they're the most efficient. And you know, that doesn't mean in every application that a spider web is going to be the best shape, but in the space that they're able to fit these ribs, it looks like a very, very efficient use of both material and ribbing. You don't want to over rib a plastic part, no matter how stiff you want it to be, because that's going to make the injection process very difficult. If they have to fill dozens and dozens of deep, tall ribs, that injection molder is not going to like you as a design engineer. But again, if you need it, if you absolutely have to have it, then you have to have it. But you know, engineering is about optimizing and making the best choice for what the application actually requires. So the next thing I see is this dust or debris guard that is basically every opening. You know, this piece fits through this hole, so there's not much of a gap there, you know, to fit much. But really every other opening has a screen. So that's definitely a cut above other ones I've taken apart in the past that just have those holes open that debris can go into. This is one of my favorite tricks right here. So that's just a nylock nut, standard off the shelf nylock nut. Something threads into here, probably a handle, could be some kind of an accessory, I'm not sure. But instead of going to the hassle of designing and sourcing a custom threaded insert that has the nylock little, you see that little ring of blue material? That's just a nylon insert, and it's a standard thing you can get on all sizes, all kinds of nuts. And so they save themselves the trouble of having to source and design their own custom threaded insert by just putting a hex in the injection molded part. So that's a really efficient use of manufacturing processes, because the manufacturing processes that make that nut are so optimized. They've been made for probably 50 to 75 years, and you can get them by the millions if you need to. So that's manufacturing efficiency. And again, I won't go over all the details, but this is a bi injection molded part, most likely, that it's in a single mold that has collapsible features, that the first material shoots into the mold and makes the blue. And then these inserts retract from these places, and then the second material comes in, and that's the SEBS thermoplastic elastomer comes in while the plastic is still hot and slightly chemically bonds to the still semi-molten plastic. So this is an injection molded part, by injection molded with the rubber as the overmold. So that in and of itself is a really cool manufacturing efficiency, that you make basically everything you see here, with the exception of the screen and the nut gets placed in after the fact, in one process that requires virtually no labor. It's an automated process that all the labor was up front in the design process and the tooling process. But other than that, really, really quick and efficient to make. So here we can see in a little more detail how that sliding electrical contact platform works. It's just got these features that fit into these sliding areas built into the mold. So not a whole lot of extra expense had to go into making that do that. A spring, and then design time of designing, these features into the injection molded piece. This injection molded piece had to be here anyway, as a termination for the electrical wires and a housing to have the contacts mounted into. So that's pretty efficient. Just added the rails into that part and the tabs into this part and a spring, and you got a really good improvement to the overall durability of the design. So if I had to guess on this piece, since it's not really a visible piece, and can you see? Yeah, this has got to be nylon 6/6. Let's see. What does that say? Yep, there. You see it? Nylon 6/6. Glass filled 25%. So one of the big tells that it's nylon 6/6, traditional nylon, is you see that the unevenness in the finish right there. You see there's like smooth parts of the finish of the plastic right there, and then there's rough. See how it's reflecting the light? There you go. See, smooth, rough, smooth. So they didn't do that to the mold on purpose. You see how it's kind of organic in the pattern. So they didn't intend to do that. That's just the nature of how nylon 6/6 traditional nylon molds. It has wonderful mechanical properties, but you just can't get, it's tough to get a good consistent finish out of it unless you really try. So if you have another compound you could use then that does better at colorability and even finish, then why not use the better material for that? So that's just interesting aside for material selection. So yeah, both of these parts are, there we go. What does that one say? Yep, PA66, same thing. Yep, and there's mold batch stamp, number for assembly. Good stuff. I'm not going to go into the electrical stuff too much. It's not really my forte. If you're an electrical engineer, feel free to comment on the quality that you see here. Everything from my experience looks really good quality here. The large surface area of these contacts, surface area is what dissipates heat. Potting compound to protect sensitive circuitry from moisture and impact. That's another thing that a lot of people don't think about with potting compound. Potting compound, depending on which one you pick, if you pick a soft one, acts like a giant airbag for sensitive electronic components. So it's not just a protector from the elements, it's also a protector from mechanical stresses like impact. So it's looks like a very high quality mechanical assembly right there, and the routing. I kind of moved this part out of here, but everything has its own exact routing ribs to keep it exactly in its place, and that's again the planning that goes into every little detail into here. Like this is where the bulk of the mechanical design went into. Maybe that and the drivetrain equally split, but housing and drivetrain, that's the majority of it. So let's just get this out of here. So this is really interesting. So you see these are motor mounts like you would see on a car or truck engine. So instead of just slapping it in there and having some ribs do the work of keeping the motor from twisting, they actually incorporated these motor mounts into that poke through the outside and actually have the rubber in between them. So that's not only is that really going to hold this motor really securely, it's also going to increase the comfort of the user, because all of that torque that's trying to twist this drivetrain as you're hammering on a bolt is going to go right through, twisting motion going to come right through to here, and then that's going to push on that rubber overmolding, and that's going to act like a damper that's going to shield you from some of that impact. So that's not only good from a strength perspective, having these giant motor mounts keeping this wrangling this motor's torque, but also improving the pleasantness and comfort to the user. That's a win-win. Now that's a beefy gear on the end of that, and that's an even bigger shaft. So they've cut that down from the size shaft it is to the size sun gear, and this is a planetary inside of there. And let me see if I can get that apart. No, so the fine people over at Bosch did not want anybody to get into this. Most gearbox assemblies have just a regular pin that goes in there, and it's kind of hard to tell. But if you can, I don't know if you can see, but anyway, I could see. Yeah, you can see if you hold it just right. There we go. So that's hollow. So what that probably means is they have instead of having a solid pin in there, they put a scroll pin, and scroll pins are hollow, and they probably designed the part that catches it on this piece to be slightly bigger than that hole, so when the scroll pin goes in, it expands, and then you can't get it out. So this is, without breaking it, this is like a permanent assembly, because they're judging by how big this gear is and how beefy that looks. There's probably some interesting tech and details, design details in here that is unique to Bosch, is what I'm guessing. And yeah, okay, so this is not metal. This is good old nylon 6/6, 33%. And so one other thing about nylon 6/6 is you can get more strength out of nylon 6. Now, strength is not the same as toughness, but if you need something to just be serious, the closest thing to metal that you could get, nylon 6/6 and 33% is pretty much the industry standard to go to for strong plastics. Again, yeah, this looks like it might, yeah, this has been painted, so they didn't have to, they were willing to put in the extra effort of painting this part. They were willing to put in the extra effort of painting this part in order to get the improved properties of nylon 6/6. So you see how unpainted and painted to look kind of like metal. So that's an extra expense that you would only go to the trouble of doing if you really needed the properties that nylon 6/6 can give you. And really, as bang for the buck, you're not going to get anything stronger in injection molded plastic than 30 to 40% glass-filled nylon 6/6. So, yeah, I'd really like to see in here and see what secrets this gearbox is hiding. But judging from the outside, I mean, this is a super nice, like that looks like a machined piece of the collar looks like machined metal, as opposed to most that I've seen are cast. So I would hazard a guess that there's some good design features and material selection going on inside of here. But that's a really good coupling design too. So to handle the torque from the driver to the driven piece, those giant dowels, circular bosses sticking off. This just screams serious durability. So, oh, that's an O-ring right there. So what is that guy doing? Okay, so that O-ring is sitting right there. Yep, that's where that goes. So just some further mechanical vibration isolation, and also possibly debris, keeping a seal to keep debris and contamination out of the motor. Not sure how the path flows through there to the opening, but it would make sense that they'd be doing a 2-for-1 with that part also. So, yeah, nothing really else I can say that boring electrical stuff, boring to me anyway, that I've said in other videos. So feel free to check out our other videos in this playlist. If you missed part 1, it should be just go back in the playlist and it should be right there. This has been the BOSCH Impactor 18-volt lithium-ion impact driver. Please subscribe, like, hit the little bell icon to receive notifications of our future videos. If you liked it, you hated it, let me know in the comments. If you got ideas for future videos, things that you'd like to see me review, please drop me a comment. Yeah, and that'll do it for this episode, so see you guys next time.